Okay, are we on the internet?
We must be.
Alrighty. Folks in Discord, go ahead and mute your mics. Alrighty. Okay, we got levels. We got streaming, we got recording. I think we're on the internet. Wow. So, hello again. This is Foghorn with another installment of Flight School Academics. Presentation topic for tonight is Intercept Geometry and Pursuit Curves. In other words, BFM 1. For this, which is the 25th of August, 2018, this presentation is part of an ongoing series of academics for the members of the Aurora Republic, a premier role-playing organization in Star Citizen. If you are new to the Aurora Republic or visiting for the first time, let me start by saying welcome. We are glad to have you with us and would love to hear from you if you are interested in hearing more from us. We are a lawful good organization focused on roleplay exploration and social interaction, and are currently active in recruiting on Spectrum and Discord. Tonight, we are going to discuss the very first concepts to come into what we call BFM. So, and some intercept geometry and pursuit curves. I have alluded to this in previous com brevity academics, so it's time to pay the bill that was promised. First, some rules of engagement. We are streaming this video on Twitch, so if you are monitoring in both Discord and Twitch, my suggestion is that you mute the Twitch audio, otherwise you will be hearing my voice twice with about an 8-second delay. I am also monitoring the Twitch chat, so if somebody posts a question in there, I will stop and repeat the question for the recording before answering. And of course, you can always come up in Discord, unmute your mic and ask a question there and just stop me as you go if I hit a concept that you're struggling with. Other than that, do remember that this Discord is being recorded and transmitted via Twitch, so anything you say in the Discord will and immediately be transmitted out across the internet. And of course, we will get the video uploaded to YouTube and the Aurora website as soon as I can when we're done. Anywho. All right, so let's get to it. So these are some interesting and can be rather large concepts. Okay. All right, so first we're going to talk intercept geometry, which is what happens before you get to within engagement range. And then pursuit curves, which is really the same concepts, but now as they're employed within maneuvering range. There are some assumptions before we start taking a look at some of this geometry. First, we are assuming that equal capability spacecraft as far as maneuvering capabilities. All of these diagrams assume steady velocities, both speed and direction. And it also assumes that we're coupled ComStab and GSafe are on. Also, please note that some of these concepts you're going to go, well, I'm not sure how to do that in Star Citizen right at the moment because some of the sensor and HUD systems and the symbology that you need to have on your HUD from your sensors do not yet are not provided yet in Star Citizen. I expect that they are coming in the future, so we're going to go ahead and start getting the academic groundwork laid now. But right now, the HUD and sensor systems do not provide the proper information for you to be able to use some of these intercept geometry. So a quick terms review from the brevity code and the subsequent terms chapter that are in the second half of our brevity code manual that I wrote for you. So this is the five big ones: range, closure, aspect, angle off, and collision antenna train angle. Pronounced kata. Angle off and heading crossing angle are synonymous terms. So depending on which particular document you're looking at, sometimes it's referred to as angle off, sometimes it's referred to as heading crossing angle. I learned it as angle off, so that'll be the term I will be using the majority of the evening. And if you're looking in our brevity code manual for collision antenna triangle, you will not find it in there because I took it out because I thought it was a rather burdensome, overly complicated concept. But unfortunately, it's one that I may have to put back in there because it's relevant to this particular discussion. So without further ado, so here we're going to go through our terms review, and we're going to use a little bit of geometry here. So as you can see, you've got the Aurora up there is the target vehicle, and the Avenger is us. That's where we're flying. So the first one is obvious. Is, let me get my pseudo laser pointer up here. Boink. Okay, so obviously range is the distance between the two spacecraft. Closure is how fast that range is changing. So closure being as the range is reducing, or negative closure or opening is how fast the range is getting larger if you're going away from each other. Aspect is the angle that you are off of the tail of your target. So at this point in this diagram, the Avenger is about 135 aspect from the target. Angle off is, or heading crossing angle. Heading crossing angle sometimes is a little bit easier for people to understand. It's literally the difference between your headings. So it's the angle from the nose of the target, which way it's heading, to the nose of you, the attacker, and what the difference of those headings are. We're not going to be using any numbers tonight, as far as this is all just conceptual. So, and collision antenna triangle, known as CATA, is the difference between the heading of the target and what the theoretical line would be to get you right to what's known as the CATA cross, or that's the actual point of collision if you flew the perfect intercept and then never flinched. The CATA cross, which is typically designated by a Maltese cross, is that spot for this given speed and the given direction of the target where you would have to point your nose to actually fly yourself to a collision. And that angle, that perfect angle between the two. Now, CATA does not equal angle off except if you are perfectly pointed at the CATA cross. So when you are on CATA, that's the only one time when CATA and angle off will be equal to each other. The intercept as it's drawn right now, where the Avenger is pointed short, being closer to the target than from the CATA cross, would be called a cold intercept. So in the time that it would take the Aurora to fly to the CATA, the Avenger would fly that same distance and would end up behind the target vehicle. That is called a cold intercept. And obviously, if he pointed out in front, then by the time the Aurora flew to the point that it would be at the CATA, then the Avenger would obviously be out in front, which is not necessarily where you want to be. That's called a hot intercept. The perfect intercept, of course, is right at the CATA where you guys meet. Okay. So I'm going to go through three basic situations. The first one is what we just talked about, when you actually are on the CATA cross, when you're actually pointed at that point of intercept out in front of the target. You're going to see that you actually have basically an equilateral triangle here, or not equilateral, but an isosceles triangle, and that CATA and angle off will be identical. What you will notice is that everything just sort of freezes, and these two craft just basically trace right up the lines as they head towards the CATA cross. The aspect will stay at whatever it is when you get on the CATA. So if in this example is 135, that whole way in, when the Avenger's here and the Aurora LN is here, then they'll still be at 135 aspect. That angle off won't change. The closure rate will be steady. The range will be decreasing, but it will be decreasing at a very steady rate. And I already said that angle off and CATA are equal. Now, believe it or not, this is all a lot of words to take in and concepts that you haven't really ever probably heard before, but your brain actually automatically understands this. And all of you who drive an automobile have already seen this in action. The target will freeze on the canopy. Okay, so as you're driving up the on-ramp onto the freeway in your car and you look out to the left here in the United States to judge whether or not you're going to be able to merge into the oncoming traffic, if that car that's in the lane closest to you that you're going to need to merge into is moving forward in the glass, then you are going to end up going behind that. You probably have seen this a million times, and your brain automatically has figured that out just by doing it a whole bunch, that, okay, and that's actually a cold intercept. If the target vehicle, that car that's in the lane, is moving is moving aft in the glass, then you are having a hot intercept. You are going to drive out in front of him and get into the lane out in front of him, which is fine. If your brain automatically understands that if that other car, that target, just freezes in the glass and it doesn't move forward or back, it's just sitting in that same spot out your side window and just getting larger and just sort of blooming and getting bigger and bigger and bigger without moving forward or back, that is kata. You are on the collision course. If you don't change something, you don't speed up, slow down, or turn, you don't change your velocity in some way. Remember, there's two parts to velocity. Velocity is a vector. So it is both a speed and a direction. Okay, so if you don't change one of those parameters, go faster, go slower, or turn in which way, when of course on a car you're in a lane, so you can't really turn, then you will collide because they're just frozen in the glass. That is kata, and that's the way it looks like. And it's the exact same in aircraft and therefore spacecraft as well. That's what that would look like. Now, this is problematic on playing a video game in a computer, because as you can see right there, in this sort of a situation where you're doing an intercept from the side, that target's going to be off the screen. He's going to be over to the left. So this might be a spot where somebody using a track IR would have an advantage because they can turn their head some and make the view that's on their computer screen turn to that where they would have their head. And they'd be able to see the target out there just staying steady in the glass and just getting bigger. And therefore they would know how to do this even without any sort of symbology from the sensors or in the HUD to help them. If you have a way to turn your character's head, which we do, and can find where that target is and basically turn the monitor's view over to where the target's within the field of view, then you could do that same thing. You could just use your eyes and just judge, is he moving forward? Is he moving aft? Or is he just sitting in one spot against the glass and just getting bigger? And that's where you'd know if you're on kata or not, and whether you'd need to adjust your heading or your speed to try to get there. Right, so the next most popular one, this is actually the one that happens the most. This is the head-on playing chicken game. This is actually how most dogfights in Star Citizen start. As you guys come charging at each other headlong. There is a kata. If you guys are co-speed, then kata is halfway between you two. That's pretty simple. If one of you is going faster, has faster speed than the other, then the Maltese cross, the kata, moves towards the slower vehicle. Aspect is 180 degrees. Okay, because you are out in front of the nose so measured from the tail of the target, you are 180 degrees. Angle off is 180 degrees as well, because he's going that way, you're going the exact opposite way. Okay, you will have massive closure. Assuming everybody's not changing speeds, then it'll be steady, but it'll be fast, super fast, because you guys are rushing at each other. This is a big game of chicken. And of course, range will be decreasing rapidly. And there basically is no collision antenna train angle because you're both pointing right at it. The thing to remember in Star Citizen when you're doing this is that don't stay on the kata the entire time. At some point, one of you needs to flinch enough to miss the other, because otherwise you guys will have a collision. And at a fast enough speed, a lot of times these head-to-head collisions are not survivable. And then there's the third situation, which is the reverse of it. This is a tail chase, where again, you guys are both pointing at the cat across, but you guys are making one big line. The problem with this is that you're not using any geometric cutoff. Unlike this situation where you're not just using the power of your motors to close with this guy. You're actually using our assumption that everybody's co-speed. Then this is all pure geometry that's going to close with your target. The tail chase situation, you don't have any geometry to use. You're pointed straight at him, and he's going the same way. So this is pure engines. You just got to speed up. So the assumption doesn't work. If you guys are actually co-speed, then you'll just sit in this position and you'll never close with him. But so you have to use nothing but motor. Your aspect is 0 because you're directly behind him. Your angle off is 0 because you guys are going the same direction. Kata is 0 by definition because you guys are both pointing at the kata cross and you have no geometric cutoff. And you only have the motors to close with them. So you gotta, it's a pure speed overtake. And typically this is the slowest of any sort of an intercept, particularly if the other guy knows you're chasing him and is trying to run away, because then it's going to come out to whoever has the faster vehicle. And in real life, more fuel. So this first little mini block about intercept geometry is really, the intercept is the gap closer. It's the opening overture to get you to the point where you can engage the adversary. And the intercept geometry changes when the target changes velocity. So if the target is not holding steady, if the target speeds up, slows down, or turns at all, then the target has moved that theoretical Maltese cross out in three-dimensional space and has moved it to a new spot. And if you are trying to intercept, then you have to flex with it and go, okay, it moved over there. I need to now turn this way, or I need to turn that way, or I need to speed up or climb or dive to get myself back on kata to close this gap. Now, I just told you that if you stay on kata forever, you are eventually going to collide with the other spacecraft, and that's not kosher. True. Understanding this geometry is how you use it to be able to close, but then at the last minute, you are obviously going to move from a pure kata intercept to something slightly cold and start actually into the dogfight, if you will. Or if they're not going to react to you, then just employ weapons and blow them up and turn at the last second. Okay, so what happens when you are in close? When you've used your gap closer and you've gotten close enough, and now it's time to start turning. Then now we're going to talk about pursuit curves, which is the turning version of intercept geometry, and it's usually within visual range, within a turning dogfight. So there are three pursuit curves: lead, pure, and lag, and we'll go through them in lead, lag, and pure as far as which order. And they're actually fairly easy to do, but they're very easy to execute, but the hard part is knowing which one you should do when. And you're going to use all three. You're going to use them in different situations, and they're going to fluidly flow between which one you're using. So lead pursuit is simply you're just going to hold your gun cross out in front of the target's motion, even as they keep turning. So as they turn, you just keep aiming out in front of them. This decreases range, so you use lead pursuit to close the distance with the target. It also decreases angle off. As you continue holding this, your heading is going to start aligning with his heading. You'll get steady closure if you hold the exact same amount of lead the entire time, but it causes an increase in aspect. As you do this, you move away from his tail and farther towards his nose as you come around him. So while it fixes range problems and angle off problems, it increases your aspect problems. And oh, by the way, if you do nothing but hold lead the entire time, if you hold it too grotesquely, you'll fly out in front of him. If you hold it where most people hold lead pursuit, it will end in a collision. So you can't hold this forever because you'll fly into the guy. Okay, so what about lag pursuit? So the opposite. You aim behind the guy with your gun cross. As he turns, you'll notice that you have increasing range. Your angle off remains steady. It really doesn't change much. You're going to have steady closure, but it's going to be going the opposite direction. It's going to be negative closure or opening. That's why your range is increasing, but it will decrease aspect. This is how you fly in behind a guy. But while you're doing it, you're giving up range. You're solving aspect problems, but you're giving up range to do it. And if you just hold it forever and you never transition to anything else, you just lag pursuit the entire time, you'll eventually end up at the guy's dead six, but you'll be way behind him and you'll be in a tail chase. So lag basically does the opposite of lead. Lag fixes aspect angle problems, but it creates more range problems. All right, so the third situation, which is pure pursuit, and that's where you just point right at the guy. You just put the gun cross on the guy the entire time and hold it. And this pretty much is a big game of ring around the rosy, and not much changes. Range stays stagnant. You're going to stay just at about the same exact range. You will be decreasing angle off, so this will slowly align your nose to his nose as far as heading the same direction, but you basically have zero closure, and you will slowly decrease aspect. So pure pursuit will end up in a big stagnated game. You will eventually roll out behind the guy, but you won't have closed any distance. So if you weren't already at a shootable distance, then you're not going to suddenly gain it from pure pursuit. All right, so putting it all together. So you're going to use all three pursuit curves, and you kind of already do, whether you really know you do or not, but understanding what you're doing will allow you to become a better BFMer. You're going to use all three pursuit curves fluidly, and you're going to flow between them in a very fluid fashion, almost to the point where when you start getting good at it, without even thinking about okay, I need to go pure pursuit. Oh, I need to go lag pursuit. I need to go pure pursuit. I need to go lead pursuit. But what you're doing when using those three different pursuit curves in a turning fight is to solve angles, solve range, solve the closure, and basically to achieve a weapon employment zone. Get yourself to a spot where you can shoot. Now, when I say a weapon employment zone, yes, you can always just point at the guy and shoot. Whether he's pointing at you, whether you're shooting at the top or the side or the bottom. But the problem is those are what we call snapshots. You might get a couple of hits, but you're not really going to saddle up on the guy like I have depicted here, where you're behind them. You're basically going the same speed. You might have a very small amount of aspect, so you're not shooting dead at the guy's tail. You're shooting a little bit at the top of the spacecraft. And you can just simply, it's much easier to, almost like a formation, follow this guy's moves as he makes turns and you know, as he makes maneuvers, because you're in that saddled position right beside him. This is where you can actually track somebody with a gun, with a gunshot, versus just taking a little snaps. And one of the things that I've noticed, I mean, it's basically the basis of dogfighting in Star Citizen right now, is nobody in Star Citizen has saddled up on anybody yet. It just hasn't happened. Everybody just fights either through a circle strafe or through just continuing little snapshots. They do a little damage, they go by. They do a little damage, they go by. They do a little damage, they go by. And they keep trying to kill each other by death by 1,000 paper cuts. Nobody has just saddled up at high 6 behind a target and just drilled them to death. I've watched everybody out there, Noobafire and all the other streamers. Nobody's done it. Nobody's done it the way it happens in the real world. So anyway, just saying that. So some closing thoughts about now versus the future. Right now, there is barriers to using these techniques, which is another reason why I was delaying going through it, because one, I was laying the foundation with the brevity. I had to teach you the language first, right? But there are barriers to use. Computer monitor right now is a barrier to use. You're looking out a small window into the Star Citizen universe known as your computer monitor. And without the ability to, and dogfights happen, dogfights happen all over the canopy. You actually never put, in a dogfight, you never put the target into what we would consider the monitor's field of view, the HUD field of view. You never put them there until you shoot them. Dogfights happen everywhere else but there. And if you're not ready to shoot the guy and you put him up into the HUD, you're actually making a BFM mistake. We call it HUD BFM, and it's actually very, very easy to set somebody up to flush them out front and reverse on them when they go HUD BFM on you. So the other one is this lack of proper HUD and sensor information. The HUD right now that they've got is extremely rudimentary. They just just in 3.0 started putting pitch ladders in when they're going, and that only shows when they're coming down into a planet, or down to a planetary body. It's probably the better way to say that. So, but we know that there's more to come there. So hopefully in the near future we'll be getting a lot better HUD information and sensor information. Current IFCS implementation is problematic. I'll be polite and say problematic. It sucks. It sucks. It's not quite the way it should be done. And Chris Roberts seems to know this. His comments a couple of weeks ago on RTV was fairly indicative that they know that their current IFCS implementation still isn't right, and they're trying to get rid of it. Basically, the way it's implemented now, it just leads everybody into circle strafe, which is not dogfighting at all. So if there's anybody out there who is deluding themselves that they're this great dogfighter because they win at circle strafe, I'm sorry, you don't even know the first thing about dogfighting yet. Circle strafe is just, Chris Roberts wants to get rid of circle strafe because that's not Star Citizen, that's Mech Warrior, stompy robots. So, and that's not what we're playing here. ComStab is not implemented correctly. It's not bad, but it definitely has a big glaring hole in it, which I'm thinking about doing a discussion of. It's not academic, so I might just do a quick video and throw it up on our media assets just to kind of tell you guys what I think about it and discuss what I think is wrong with it. But the good news is things are changing. They have talked to it, so I think it will get better. And therefore, that's one of the many reasons why we're going over this now. We're going over this first little baby steps of pursuit curves and intercept geometry. Because I'd rather get you guys being able to talk it and start thinking about it now, when it's all just theoretics, for when things do change, then wait till they change and now then try to get you start throwing you in the deep end. So anyway, thank you very much for your time and attention. I hope it wasn't too boring. I hope it was fairly quick. Nobody stopped me with any questions, so this wraps up this installment of Academics with Foghorn. Hope you found it interesting and helpful. If you have any questions,
like to ask you a question.
All right, you got a question? Awesome. What's up?
Yeah, when I've played flight simulators, I do most of my turning by rolling and then pulling my pitch, as opposed to yaw turns. But in Star Citizen, it seems to be built around yaw turns and not a whole lot of rolling. Where do you think we're going to end up, and what is the preferable way to actually do this?
My short answer is it does not matter. In 6 Degrees of Freedom, whichever way that the vehicle will turn, just because I have these drawn as looking at the edge, these guys being a pitch fight, they're turning in pitch. I could turn these pictures 90. I could turn the vehicle, I could roll the vehicle 90 degrees so that you're looking top down on these, and these curves would still be true. So it really doesn't matter whether you're doing it in pitch and yaw or, in pitch or in yaw. The curves, the concept of the curve, and whether you're pointing in front, behind, or directly at, and what it does to your range, angle, off, and aspect and closure, are all true, regardless of which way you're turning. Did that answer your question?
Yes. Thank you.
Yeah. Now, flight simulators in atmosphere, you're using wings instead of thrusters. You're using wings to generate lift. So your lift is your lift is your largest force on an aircraft. So it's much more efficient for an aircraft to roll and point its lift vector, which goes straight out the top of the airplane, in the direction you want to go, and then pitch the airplane around to that heading and then roll out. It's much more efficient. You actually can turn the nose of an airplane completely with yaw, with the rudder, but it's extremely slow and extremely, because the rudder is the smallest flight surface, and therefore generates the least amount of force, and will turn you the slowest. So it's just a what gets you there fastest game there, which is why aircraft all fight with pitch. It's all pitch. It's just you roll to orient which way pitch means now.
That more answers my question.
Yeah, in space, theoretically, if you looked at the stats on a spacecraft in Star Citizen, and if when it gives you the degrees per second in roll, pitch, and yaw, if you looked at the yaw and the pitch degrees per seconds and they were different, then whichever one was the fastest would be the best way for you to always turn. So if a Star Citizen spacecraft pitches faster than it yaws, then it would be you more advantage to roll your orientation until you are pitching around your turn versus yawing around your turn, and vice versa. If yaw was the bigger number, and I don't think most of them do this. I think most spacecraft, they have them balanced, so that pitch and yaw are basically the same number. But if they're not, if yaw was bigger than pitch, then you would actually be better off to constantly roll to orient the fight left-right so that you can yaw around the turns if your yaw is faster than your pitch for that spacecraft. Also remember the effects of G, because I did not talk anything about G in that. Pitch, positive pitch has caused positive G. You're going to gray out or black out if you go long enough. Negative pitch creates negative G. You're going to red out, or if you push it far enough, you're going to have a stroke and die. So, you don't necessarily have as bad of that problem in yaw. So there's actually a few people who actually fight that way. There's a great video out on the internet of I'm sorry I can't remember the guy's name, but who did one lap around Old Vanderval in I think it was the Razor LX, in some insanely small number, like 36 seconds or some crap like that. And he did it basically by every time he was going around something anytime he was going to turn that would, cause G-forces, he was always rolling to orient it so that it was a left or a right turn. So he was going around knife edge through a lot of these. He turned what most of us would go through and make a big pitch change. He turned it into a yaw change so that he could so he could avoid blacking out. There's a whole bunch of other really cool things he did, but that was one of the things I noticed. I was like, oh, dude, he's controlling whether or not he's controlling the G effects on his character by how he's orienting before so he can just, hammer down on the afterburner and just keep it welded the entire time and keep his thrusters full boosted so that he could just rip around those corners at the maximum performance of the spacecraft, which I was thoroughly impressed. Because I spend a lot of my time out on the race course smashing into things, and that pisses me off. Any other questions?
So in the future, the plan is to implement atmospheric flight models, and that will probably change. Obviously, spaceships that have wings or approximative wings are probably going to have a fairly high advantage in atmosphere versus thruster-based ships.
Exactly.
So you're going to have to learn to fly kind of two different ways, theoretically.
In theory.
In the same ship, perhaps even.
Yeah. Yeah, and that's the way it is, I mean, the space shuttle flew very different out of the atmosphere than it did in the atmosphere. If we use the word fly, considering they came down just as a glider, so. But if it were me, and I'm, if it were me, most of the spacecraft in Star Citizen would never fly in atmosphere. If it were me, because of their lack of aerodynamic shape, the Aurora, that's never going to fly in the atmosphere. You put that into atmosphere at any sort of rate of speed, and that thing's going to immediately go out of control. Same for the Mustang, definitely the Freelancer. You know, there's the Sabre would probably be okay. The Hornet, the Hornet would be grotesquely longitudinally unstable. Yeah, it has wings, but it has no tail. Have you noticed that? So,
I thought it had two.
Well, those two little things kind of coming out the back past the engine. It doesn't have anything that's a rudder.
Okay.
You know, you follow?
They're about as useful as a PTO.
Exactly. So they're I know there was a lot of people that went, back when they were like their original 5, you know, the Avenger, the Hornet, the Sabre, blah blah blah, that they got a lot of feedback from the community. I think they were listening to the wrong people, but apparently they got a lot of feedback from the community. They're like, "Oh, your spaceships look like airplanes." Well, if they're going to fly in atmosphere, they better. You know, they better look like airplanes, because if you bring a constellation into atmosphere, they should plummet to their death no matter what, because with any sort of speed, if they come into atmosphere with anything that looks like speed, the constellation should plummet to its death, because that thing has no aerodynamics built into it whatsoever. You know, and I'm actually okay with that. I'm okay with space, you know, with the spacecraft having to remain in space. You know, I mean, they're already going to have to do that with like the whole D's and whole E's, maybe even the whole C's. You know, so I mean, if you got these big bertha ships, you know, not everything is supposed to come down into atmosphere. Have your, you know, but your fighter jets, your fighter spacecraft better be able to handle both, or else they're not going to be very useful if you're doing any sort of ground action. So, just my thoughts.
Can I ask?
Yeah.
Oh, can I ask a question?
Yeah, please.
In our spacecraft we have vertical and inverse vertical thrust, biffing, like a Harrier. I've been using that a lot in combat. It does tend to get me out of a pickle.
Yep.
Are we going to be covering any of that?
These, like I said, the pursuit curves don't matter what your orientation is. It works either way.
Right.
In other words, you could do that exact same thing thrusting in the vertical the entire time.
Yeah, okay, that's what I've done in a couple of contact. Also, one of the guys that owned me a couple of weeks ago definitely does this for real, because he had shots on me continuously.
Yeah.
While I was complaining about being shot up.
There's some great Mech Warrior players out there who are playing Star Citizen. There are some circle strippers.
Is that what it was?
Well, I mean, that's my opinion. I don't know. I don't know who it was you're fighting, and I don't know what the guy's background is or any of that. And I used to play Mech Warrior too, so, you know, if I'm on a decent machine that's not getting, you know, if you're fighting somebody and you're only getting 10 frames or 15 frames, you're at best seeing half the fight.
That's true.
Okay, I mean, because I will fight. I've fought Bill a few times, and I fought Matt a few times, and they're running, you know, 35, 45 frames, and I'm running 10 frames on the. I'm not even seeing half the times or a third of the times that they're hitting me. It's just, I mean, I would literally go, okay, we're coming in, boom, boom, and all of a sudden I blow up, and I'm like, I didn't even see you shoot me. You know, because if you're getting a significantly different FPS than the other guy, well, then, you know, he's seeing the world at 4 times the fidelity you are, if that's the difference between your FPS, right? So,
can you invite me, Mr. Horn?
Invite you.
Are you in Arena Commander now?
Not yet. Not yet. We were just finishing up. I was just taking questions at the end of the presentation, at the end of the academics. So, anything else from the quorum? Going once? Going twice? All right, folks, this wraps up the installment of Academics of the Foghorn. I hope you found it interesting and helpful. If you have any questions I didn't answer, please feel free to contact me via email, Discord, Spectrum, or, of course, the comments section below for the YouTubers later. And I will answer to the best of my ability and as quickly as I can. If you are part of the Aurora Republic membership and you haven't hit the subscribe button or follow here on Twitch, please do so immediately. If you are a visitor to the channel, please also feel free to hit that subscribe button or follow us on Twitch and give us your feedback, because it really does help us as we're always striving to improve our content. You can find out more at our website, which is aurorarepublic.space, or, of course, on the RSI website at robertspaceindustries.com/AuroraRep. And obviously, if you found us here on Twitch or YouTube, I don't need to tell you how to get here. I'll see you next time. This is Foghorn signing off and wishing you a pleasant remainder of your morning, afternoon, and or evening. Thank you very much.